everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up 65 is on the screen. By now you should be experts at those. So I'll give you some time. After that, get a Cornell note ready. And pay attention to this part. I want you to create a coordinate plane from negative 10 to 10 on the x and negative 10 to 10 on the y. It should fit on half of your paper. Half the page, the entire coordinate plane. Okay? Once you finish the warm-up, though, you're like, you don't want us to get one from the back? No! Make your own. All right? Then we'll get started. Go. All right, as you're sending me that work in, we said, who was going to get us started? Oh, Anthony E. Oh, thank you for reminding me. Anthony E. For number 1, complete the square. What do I write? Plus what? Plus 18 over 2 squared. Hands if you wrote that so far. Okay. Which gives us x squared plus 36x plus 18 squared, which is pass someone, Anthony E. Yeah. Oh, I see. So this is 9 squared, which is 18 divided by 2 is 9 squared is 81. Ah! Hands if you got something like that. Okay. Once again, 18 divided by 2 is, wait, where did we write 18? Anthony. We should have written what, guys? 36. My bad. 36 divided by 2 is 18 squared, which is 300 and what? 18 times 18. 324, you said? Is it 324? Yeah? All right. So therefore, factor form should be x plus 18 squared. Hands, have you got that? All right. 2a, Mr. Q. This is 6i. 2b. Share with your neighbor, and Jaden's going to pass it to someone. What'd you get for 2b? 2b. Jay, pass someone. 7. Square root thingy 3 over 3. Hands, have you got that? Looks about right. Let's go to number 2c. Approximately what? Show your neighbor. Bailey's going to pass someone. Square root of 55. Pass someone. Bailey. Andrew. Square root of 55. You say what? Right. Let's go. Help him out, Anthony D. Approximately 7.6. Hands, have you got something like that? Okay, pretty close. Number 3. Factors for number 3. Share with your neighbor, and Anthony's going to pass him one. Factors. Pass someone, Anthony. Bree, what'd you get? X minus 8 and x plus 3. Hands, have you got that? Looks about right. And last but not least, we need an inverse for that one. At the end, you should end up with f inverse of x equal to something. Show your neighbor. Bree's going to pass it out. All right. Pass someone, Bree. Nitos, what'd you get? over -6. And that is correct. Make sure you send that in. Copy the agenda, please. Agenda for today, warm-up number 65. We're still in the middle of transformations of functions. Today we finish up the last parameter up to right now. We're going to add one more. Yeah, let's go. Tomorrow's Friday. Come on now. Bring it. Second semester 2024 has got nothing on us. And home plate for tonight, 5 transformations only. So far, how are we been doing with the home plate? Yeah? Okay, good. Thank you, Mr. Q. You're welcome. I got you. Get home, get your flaming hot Cheetos, and get to work. Bam, let's go. All right, we good? And the code for today's presentation, HX7ZQ. HX7ZQ. All right. Thank you for submitting your warm-up. Appreciate it. There's tonight's home play on your screen, but you already have the code. All right, get a Cornell note. And once again, on your Cornell note, I want you to put a coordinate plane from -10 to 10 on X, -10 to 10 on Y. Make sure it fits on half a page. Turn the paper over and do another one in the back, please. 2 of them. Bah. Oh, and by the way, last night's home play was this one. It's free from me to you. Thank you, Mr. Q. You're welcome. I got you. Yeah? Yeah. Somewhere like, Mr. Q, but I spent like a long time doing that. That's good. Good to put in some work on your own. Let's go. Yes, sir. B. Yes. And we're going to see that today more. Give you some time to set up your coordinate planes. Make sure you trace them nice and straight. Make sure the tallies are evenly scaled. If you need a ruler, there are rulers over there on that box over there. Help yourself. Here we go. I can transform a function using different parameters. Share with your neighbor the definition for functions. By now, they should be experts. We'll have Anthony share out loud in a little bit. Definition for function. Anthony. D. Definition. Oh, snap. He sounded like he was reading, my goodness. Woo! Did you ever hear that one? A relationship that has exactly one output for each input? My goodness. You remind me of me in kindergarten. All right. We got that. All right. From there we went to this one, yes? Did we end up with this one yesterday? Remind your neighbor, what do you do with this 2 right here? Remind your neighbor, please, what do we do with that in order to rewrite it? Please, pretty please, before we move on, what do we do with that 2 in order to rewrite it? All right. What do we do with that 2 to rewrite it? Brandon Darty. Make it a fraction of 1/2. Yes, because there's an invisible 1 right here. So that means this with a 2 becomes a 1/2. So g of x equals 1/2. So that means this plus that. It makes it a fraction. And we're left with f of x minus 2 plus 3. And that's to the what? 2nd power. Now, do we need to do this one again? No, we did this yesterday. I'm just recapping. Don't copy that. Yes? All right. From there, we went to something like this. Yes? Then from there to this one. So you have a blank coordinate plane, Julia, yes? All right, so let's see. I'm going to pause the tunes in the back. So I want you to graph me a quadratic function. I'll give you 20 seconds on your paper. Do that right now. Quadratic function. By now you should know what I'm talking about. Quadratic function. All right. Should be just about done. All right. So I'm going to write it over here so you guys can see what I'm talking about. You should have graphed f of x equals x squared. Is that correct? That's a quadratic function. And you did negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And you label that f of x. Hands if you got that? Yes? All right. I'm going to switch colors now. Write this one on the left, and then I'm going to give you one in red. Use whichever color you have different from your pencil. And I'm going to write g of x equals parentheses x minus 6 plus 2. So, transform this original f of x to that. Before you do, share with your neighbor what you're going to do. Share with your neighbor before you start doing what you do. What are you going to do for that? Share with your neighbor. And then sketch that last function. Go. All right. Should be just about done. Then we'll have Brandon share out loud what he did for that last one. All right, what are you doing with those 5 points, Brandon Darty? To the right 6 and up 2. And tell your neighbor what's missing from that last transformation. What's missing? Look at it. What's missing? Tell your neighbor. Yes, we're missing parameter A. What else is missing? Yeah, the squared. From now on, I'm not going to use the f anymore. That's an understanding that we know that we are dealing with a function. So I'm trying to transfer you now that we're no longer going to be using the f inside of the new function. So here we go. 6 to the right and 2 up. So I'm going to start with this one. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6. 1, 2. Is that 6? Yeah. And then 1, 2, 3, 4, 5, 6. 1, 2. And then 6 and 2. Oh, yeah. Let's go. And we're going to label this g of x. Okay. Next, I'm going to switch colors on that same one. I'm going to use blue this time. And instead of g of x, this time I'm just going to use a different letter just to distinguish that we're on a different one, but same from the parent function. I'm going to use h of x. H of x, parentheses, x plus, give me a number, 4, square, minus 3. So you have the parent function, which is f of x equals x squared. Tell your neighbor what you're going to do to graph this one. Tell your neighbor. Then we'll have Brandon share out. All right, what are we going to do, Brandon? Felix. Down 3. Less 4. hands. Have you got that? That is correct. So I'm going to take this one down 3, left 4. 1, 2, 3. 1, 2, 3, 4. This one 1, 2, 3. 1, 2, 3, 4. This one 1, 2, 3. 1, 2, 3, 4. Wait, hold on. 1, 2, 3. 1, 2, 3, 4. This one 1, 2, 3. 1, 2, 3, 4. Wait, did I make a mistake? Let's see. 1, 2, 3. 1, 2. Oh yeah, it should be right here. Sorry. Wait. Let me get started again. Yeah. I'm bugging, right? 4 to the left, 3 down. So I got 1, 2, 3, 4, 1, 2, 3. There you go. 1, 2, 3, 4, 1, 2, 3. Then 1, 2, 3, 4, 1, 2, 3. The other one's only 1 step away, 2 steps away, and a 0. All right. And we're labeling that h of x. Hands, have you got that? All right, so far so good, yes? All right, so let me pause the tunes in the back. I just wanted to show you something really quick. So, we started off with f of x equals x squared, yes? All right. And it's this one. And notice these 5 points don't change, but which is the one that's very peculiar that doesn't change on all 3 different functions, which is what? 0, 0. We're going to call that the vertex. You guys remember the vertex? Yes? Algebra 1, your favorite? Yeah? So we call that the vertex. And it's at what? 0, 0. All right. That's our vertex. Label that, please. Vertex. All right. So tell your neighbor the vertex for the red one. What is the vertex for the red one? And write it out. Vertex for the red one. Tell your neighbor, please. And we'll have Brandon Felix pass it to someone. The vertex for the red one. Vertex. All right. Brandon, pass someone. Danny? Oh, Martin. All right. Martin, vertex. It's right here. 6, 2. Yeah, write it out. 6, 2. And with that said, tell your neighbor the vertex for the blue one and write it out. Vertex for the blue one. Vertex for the blue one. All right, tell your neighbor what you got. Vertex for the blue one. And then we'll have Trinity share. Trinity, vertex. -4, -3. Okay. So, here it goes. Writing utensils down, look up to the screen. Without saying a word, I'm just going to use my Jedi Star Wars powers. Here we go. Original, vertex, 0, 0. Red one, blue one, tell your neighbor what you just saw. Tell your neighbor what you just saw, please. What did you just see? Looks like Anthony E's got it. Very good. Noah's got it. All right. Jaden's got it. Of course, he's pointing to it. All right, good. All right. Maya G's got it. Very good, Maya G. But let's ask Anthony E. What do you see, Anthony E? What has the same numbers? the equation. So let's go to the red one. You guys see that? He said they have the same numbers as the vertex. So let's see. This one is there, and this one is here. Oh, Anthony, let's go. From the corner. Reminds me of me in kindergarten. All right? Let's see if it works for this one. This one is also here. And this one, remember that we should have a negative here, which means this should be a what? -4 that we substituted in there. There it is. So guess what? On the side, I want you to write this out. I want you to write from now on, the vertex is always what? What does the 2 and the -3 represent? What is it? Yeah, H and K. That is correct. Let's go. Oh, yeah, H and K. All right. And we already know in regards to compression and stretch, yes? All right. Shall we do one of those? No, we already did that yesterday. So today I want us to move on to the new parameter, okay? So turn your paper over. Let's go to the new graph. And sketch this one. It's a cubic, and write this on the top left. I'll give you some time. We're going to do this one together. Give you some time to set that up. Go. Ready? Yes, Mr. Q. All right. So with that said, since we're going to be graphing without tables whenever we start with our parent function, and then from there we're going to ask you to move it according to the parameters. But today, to show you the new parameter that I'm introducing, let's make a table for our original function. So here, I want you to write x, f of x, and we have -2. -2 corresponds to what? -8. -1 to -1, 0 to 0, 1, 1, 2, 8. All right. Do we have those points here? Yes, there they are, Mr. Q. All right. So now we're going to switch to blue so I can show you what this new parameter is going to do. If you notice, now we have a fraction in front of the x inside of f of x. Okay? So, with that said, let's make a table right next to that. X, we're going to still use the same values, -2, -1, 0, 1, and 2. Nice and straight like mine. And here, I want you to write f of 1/2 x to the 3rd power. All right, so let me zoom in. Here we go. I'm going to use this new transformation using the x value given. So, and like I said, I'm going to try and use what we're doing, the function, but without the f, because the f is just there. I'll put it for this time. Here it is, f. Then we got 1/2 times parentheses cubed. So you remember what I'm going to write here in this empty space. What do I write there? -2. That is correct. -2. Therefore, -2 times 1/2 is -2 over 2 cubed, which is -1 cubed, which is -1. Next one, f of 1/2 times -1 cubed. Okay, so let's see. What is 1/2 times -1? -1/2 cubed. Now, mind you, this negative stays negative here because it's an odd exponent, or negative times a negative is a positive times a negative, it's still a negative. So my answer for this one is also going to be a negative. So we got that. Okay, here it is, negative. However, check this out. Look up. Whenever you end up with a fraction here, you do the exponent for the numerator and the exponent for the denominator. So what is 1 cubed? 1. What is 2 cubed? 8. There you go. So our answer is negative 1/8. All right. Now that you saw the process, finish up the last 3 cells, please, by yourself. All right. Don, tell me what to write. S of. Oh, you're coming, Don? Okay. Tell me what to write, Dom. So this times that is 0. What is 0 cubed, everyone? 0. All right, there it is. Okay. Next one. Help me out with the next one. Vianney, tell me what to write. Which is 1/2 cubed, which is 1 cubed is 1. 2 cubed is 8. That is correct. Hands, have you got that so far? Yes? All right. And last but not least, tell me what to write. Jaden, go. 1/2 times. Positive 1. All right, we got it? All right, I'm going to zoom out because we need to graph this now. Here it goes. Let me zoom out. There it is. So I'm going to graph this. What am I going to graph? The x value is -2, and the f of x is -1/2. Let's start with that. -2, -1. I'm sorry. -2, -1. -2, -1. Here it is. Plot your point right there. Let's go to the next one. -1, -1/8. -1, -1/8. Look up. It's very close to the x-axis. Let me zoom in so you guys can see it. -1, -1/8 is right around there. All right. Then 0, 0. What's the next value? The next value is 1 and +1/8. 1 and +1/8. Here it is. 1 and +1/8 right here. And what is our last coordinate, Danny? So it's what? What is 2, 1? Okay, so 2, 1. It's right here. All right. So sketch your new transform function. Whoa, sorry. Let me zoom out. Look at that. On a white shirt, Q merch, let's go. Put it on my YouTube channel, right? So, look what happened. Now we have this inside here with the x, and this is what happened to the original. So, let's think. If you had a little person in your life that's always asking you questions, and they came in and saw that, what are you going to tell them happened to the original one to get that blue one? Share with your neighbor, and then we'll I'll pick someone to share out loud. What are you going to say happened to that one from the original? All right. So, what do you say is going to happen to that one, Selena? It got compressed, okay, but did it get compressed like this? Because if it gets compressed like that, then it should be somewhere tighter than this, maybe right here. But who notices that it's a little bit more like going in that direction like this? So it's going in what direction? Horizontally. Horizontally. So today I'm introducing a new parameter. Now, mind you, look up to the screen. Isn't this one always there invisible in front of the x? So we're only introducing a denominator, and the denominator being a whole number, right now we're going to say it does something to it. So do this. Write this down, please, on your paper. Here's now our new general rule, including the new parameter b. G of x equals a times f, parentheses, 1 over bx minus h plus k. So, get us started, please. What does k do? K for Kimberly. Up and down, that is correct. Put an arrow here. Up if it's a positive. Down if it's a negative. That is correct. All right, so far so good. What does h do to the entire function? H for Martin. Right. Right. If we substitute a positive number. Left if we substitute a negative number. Okay, so far so good. And then when we introduced a, we said that a does what, everyone? A stretches. If it's a what? Whole number. Or compresses if it's a fraction, or decimal. However, it stretches or compresses, I want you to write it out, vertically. Vertically, that means up and down, stretch or compress. So with green, circle or box, B. It's going to stretch or compress. Same thing, stretch if we substitute here a whole number. Compress if we substitute a what? Fraction or decimal. But in which direction, everyone? Horizontally. Horizontally. Sideways, like this, like an accordion. All right? All right, so I'm going to send you a blank screen just so that, not that I don't think you're taking notes. I just want to see how beautiful your notes are. Send me your notes, please, on your screen. So far we have this general rule, and if I gave you the value of each different parameter, you should know what it does to the original function. Yes, am I right? Am I right? You're right, Mr. Q. All right, good. Thank you. All right. David, you good? Yeah? All right. David says, come on, Q. Give us a pop party. Let's go. David for Presidente. All right, so here's our general rule, and I'm going to play a little memory game with you to see if how fast you are and telling me what, depending on which value I give you, what it does to the function. All right? So I'm going to start slow just to make sure that everybody's keeping up. Here it goes. I want you to look at your screen. Let me send that over. Hold on. All right, here it goes. Look at your screen. Here's the original function. There it is. According to the general rule, tell your neighbor what would happen to this original function if I substitute -1. Tell your neighbor first before you write it on the screen. What's going to happen to the original function if we substitute -1 for a? All right, let's see. How about, let's get back at on this. How about Emily P? What do you think would happen, Emily P, to this original function? It would flip it upside down. Let's go. Tell your neighbor why. Because it's a what? A negative. That is correct. Write it on the screen. Send it in. All right. So, set your notes aside here. It's going to go pretty fast. Ready? Here it goes. Let me bring this over here so like that I can use this. Oh. Here it goes. Next one. What does this one do? Write it on the screen. What will that do to the original one? What does that do to the original if we substitute a 2 in for a? Laura. Stretch it. Which direction? Vertical or horizontal? Vertical. That is correct. Thank you. Let's go to the next one. Look at that one. If we substitute 1/2 for a, what would it do? It would do what? Compress. That is correct. We'll stop right there. Make sure you have the code for the home plate. Practice that at home, because tomorrow's Friday. Remind your neighbor what's happening. What's happening tomorrow. Later, guys. Enjoy your home plate. See you guys tomorrow. Bye. But you got to have